11 general turn to SBQ1. What is the work done by gravity as gravity if the ball weighing 45 Newton falls as well? So basically the displacement is downward, so the work cannot be negative. Finding the work is F by D by cosine of 0 here, because in the same direction it will give me 45 times 1.5 times 1, it will be 67.5. Now we have a graph of force displacement. I need to figure out the work at 3 meters. So I simply will find the area. So the work is the area, which is half base times height, which is equal to half by 3 by 45, giving me 68 joules. Question number 3, I need to find the net work required to accelerate a 1000 kilogram car from 20 to 30. So here the work is actually the change in kinetic energy, which is the final kinetic energy, not the velocity, minus the initial kinetic energy, replacing everything by its value. So 1000 times 30 squared minus half by 1000 times 20 squared, it will give me 250,000. Question number 4, we have a car traveling at a constant velocity, covers a distance 100 in 5 seconds. The thrust of the engine is 1.5 kilo Newton. So basically, because I have my answers of power all in kilowatt, there's no need to convert the force. So the power is eventually the work over time. The work is force by distance over time, meaning that it is 1.5 by 100 divided by 5, it will give me 30. Question number 5, I have a book that is lifted and then 1 meter and then return to its original position. So basically here the displacement is 0. So positive and negative work, or let's say just the displacement is 0. So basically here there is no work done during this process. A force of 10 Newton is applied to a block, pulling it 50 meters along the ground as shown in the figure. How much work? I have the force magnitude D and cosine of theta. It will give me 10 by 50 by cosine of 30. So the answer is in joules. Now, true or false, the work done by friction has a positive value? No. Whatever was the displacement, let's say, whatever was the displacement, the force of friction is always opposing the motion with an angle of 180, so this is false. An object has a kinetic energy because of its motion and mass. Yes, that's true, because the kinetic energy is half mv squared. Motion for v and mass. Kinetic energy of an object can be negative. I don't think so. This is false, because neither the mass nor the velocity squared can be negative. An object's rest energy is equal to the mass times c squared is equal to its mass times the speed of light squared, which is true. Number 4, I have 4 forces. They do the following amounts of work in the indicated times. Rank these forces in order of increasing power. There may be some ties, so let me find the power for A, which is the work divided by the time. So basically that's the the general formula. For A, I have that the power equals to 5/10, giving me 0.5 watt. For B, the power is 3/5, which will give me 0.6 watt. C, the power is 6/18, which will give me almost 0.3 watt. And finally D, with the power equals to 25/125, which will give me 0.2 watt. So increasing order, yani this means that I need to start from the least to the greatest. So D, then C, followed by A, and the largest is B. Number 5, I have a bicyclist that increases her speed from 4 to 6, and given the mass is 55, I need to find the work. The work is the final kinetic energy minus the initial kinetic energy, which will give me half by 55 multiplied by 6 squared minus half 55 as well multiplied by 4 squared. Okay, so 36 minus so the answer is 550 joules. Now here in the table below, I have to draw an arrow for each of the cases that shows the direction for the force acting. So here the work is bigger than 0, so it is positive. The force should be in the same direction as the displacement. However, here the work is 0, so either there is no force, but I need to draw a force. I either draw it up or down in a way that makes it perpendicular. So I chose here up. However, for the work to be negative, I have to choose an opposite direction for the displacement, which is backward. Thank you.